Good morning, good evening, good afternoon, everyone, from wherever you're joining in. My name is Prithviraj, and I welcome you to the CNCF webinar on celebrating 1 year of Kordent, a tool which has helped orchestrate platforms since the last year, a very popular tool used by different community members, especially in the CNCF ecosystem from the K0s Cosmotron background as well. I would like to start off by introducing ourselves. My name is Prithviraj. I'm a CNCF ambassador and a community manager and developer advocate at Mirantis. Uh, we have four folks who have contributed to Kordent since the last 1 year, have been pretty vital in bringing up the subcomponents of Kordent. We'll start with the introductions. Ekaterina, you can go first.
Thank you, Prithvi. Hi, everyone. My name is Ekaterina, and I'm a developer on the Kordent project, where I currently work as part of the cluster management team. I've been with Kordent for more than a year now, essentially since its very early days, and that gave me an opportunity to see how everything has evolved, to work and collaborate closely with an amazing group of engineers and help them strengthen core cluster management behavior. And that's it from my side. Passing the ball to Wahab.
Thank you, Katarina. Hi, folks. I'm Wahab Ali. I have been with Mirantis for around 6 years at this point, and I started working in Kordent. I've been working in Kordent for about a year now, and I joined in when Ekaterina and some other engineers had already laid down some of the initial code base, and I came in when we decided to implement some state management for Kordent to manage the clusters that we were creating. So it's been really nice working with all of the folks, and it's been a learning experience for me as well. And I hope that we continue to work on this project furthermore. Thank you so much. So I guess I'll pass on the mic to Dennis.
Okay, hello. So my name is Dennis. Me and Alexei, which is also on the call now, are part of Kordent Cov team, which is Observability and FinOps. So we are trying to bring all these metrics and logs and traces to the dashboards so that you could see what's happening in the clusters. I really enjoy working here for almost a year now, and let's bring even more value to our users. Cheers.
Alexei, can you introduce yourself as well?
Yeah, hi everyone. I also joined the Kordent team about a year ago, working with Dennis on observability to automate everything that whenever people provision Kubernetes cluster, it could be managed and handled properly from operations team to look at all the metrics and data there. I'm happy to be the part of Kordent community and team. Thank you.
Thank you so much, everyone. That was a quick introduction. Again, glad to have you all here to share the updates with the community. Next up, a quick roundup on the agenda. We will, of course, talk a little bit about 1 year of Kordent, how we are celebrating or what we have achieved in terms of releases, numbers. And of course, we'll have a conclusion as well, where we'll talk about a little bit on the stats or call to action. And then, of course, post discussing a little bit about Kordent, what's it about, we'll have Ekaterina, who's going to share quickly updates on the Kordent cluster management side of things. Then we'll have Wahab, who's going to share updates on the state manager side of things. And then Alexei and Dennis, Dennis especially, will chip in with the updates on the Kordent observability and FinOps side of things. So let's get started without any further ado, a little bit on 1 year of Kordent, just some numbers. Kordent 0.1 went GA on February 6, 2025. It's around a year. We are recording this on 18th of Feb, and hopefully this goes live next week. It's been 1 year of development, contributions, and usage. Of course, we jumped ship to 1.0 pretty early. In its life cycle, I think it was around May. And then right now, Kordent is already live with version 1.7. We have gone through a lot of improvements, which our speakers are obviously going to talk about. The community grew fairly, and our community calls started around June 2025. And of course, the Kordent community is hosted on the CNCF Slack. There are around 150 members now, and then you've seen some folks who are utilizing Kordent also on the k0s Slack, or the platform engineering Slack, or on the Kordent YouTube channel as well. And then we have seen other participation at different KubeCons or other conferences, especially around the cloud native or the AI stack. So that's a little bit on how Kordent has progressed in terms of community. And of course, we'll be discussing a little bit on the roadmap. We are envisioning a little bit on Kordent 2.0 as well. So that's something for the future, of course, but our speakers are going to share how each subcomponent is envisioning its roadmap, at least in the near future, up next. So let me start by introducing Kordent for folks who are not aware of what the tool is, or for folks who have not really read through the CNCF blogs or the webinars we have done in the past. I'm not going to start from scratch, which is a little bit on platform engineering, but I'm just going to start with a little bit on platforms and how we are envisioning it for tomorrow. These are some tooling I have taken in from three particular aspects. One is, of course, after your infrastructure layer or the base of your environment, which can be a public cloud environment or an on-prem environment, or if you are hosting your platforms, infrastructures on bare metal servers, edge environments, comes the cluster or the composition aspect of it, or the cloud composition aspect. And that is where a lot of folks are utilizing Rancher or Cluster API, especially on the open source aspect, where we're trying to manage different clusters, different applications. And then comes the policy aspect, or the services aspect, where you're using different services or controllers. It can be an ingress controller or different services. It could be on the policy side of things, resilience management side of things, or your eBPF, Cilium, of course, a popular eBPF tool. And then comes the observability and the cost optimization aspect. I know a lot of folks haven't really moved on to the FinOps side of things, but again, I feel that cloud cost optimization, the aspect of saving costs or optimizing your cloud usage of different tooling is again an important tool. And how can you even have a platform without having, of course, the IDP or the developer platform, but also your observability stack, which includes the monitoring, logging, and tracing side of things. So this is how we envisioned a platform, or the internal developer portal of tomorrow. And the idea was to solve these three main problems. One of them, of course, was managing your clusters. There are a few tools out there, but the idea was to because it became so tough to host, say, an instrumented cluster API, the idea was to have a simpler version and make sure that it's repeatable, automated in some forms. And of course, then you have the state management side of things, as I spoke about. The idea was to ensure that the beachhead services, any service that you're using, the CSIs, the CNIs, you're able to manage them well with an add-on controller option. And then, of course, the observability and FinOps side of things, which I said is essential. And the idea was to complete this platform and evolve through the Kubernetes way of doing it. So this is where I feel Kordent has come forward from the pre-distribution mainframe frames era, where the advent of Kubernetes started back in 2013, 2014, and Kubernetes curated or formed the CNCF Cloud Native Computing Foundation as we know today. Moved on to the OpenShift era, the Docker containers era, included a lot of enterprise versions as well. Every cloud provider came up with a Kubernetes offering packaged for enterprises. And then the idea was to create lightweight Kubernetes with K3s and micro KTS. And then k0s, of course, as people popularly know, a popular CNCF project today. The idea was also to host multi-cluster, multi-cloud environments. We saw the advent of projects like Karmada, or even we are seeing a lot of new projects coming in. But I feel Kordent is a pioneer to the newer generation, the generation that started a couple of years ago. Of course, orchestrating major workloads, multi-cloud environments, alongside hosting, services on edge or IoT environments, and then the multi-cloud version of things where workloads are hosted on bare metal servers and different clouds. I know organizations which are hosting their environments on different clouds, and that's where Kordent comes as a pioneering project. And the idea behind Kordent is nothing but to ensure that you have a distributed infrastructure, a distributed platform being managed as a single source of truth. So in my opinion, or as we know, Kordent acts as a super control plane with its components, cluster manager, state manager, FinOps and observability, helping manage your different applications, your different clusters as a mothership or as a platform orchestrator. And of course, the platforms are composable in nature. It's trying to be an enterprise grade open source tool, curated, packaged, and maintained again in an open source way with a fine community and a community driven methodology. So that's about Kordent. This is what I've spoken about. It's designed as a super control plane. It helps you manage even if you are on 5 clusters or 5,000. It's multi-tenant in nature. You can manage your air-gapped environments even if you're deploying your services on a public or a private cloud or a hybrid cloud. And again, the idea is to maintain visibility across your clusters. Clusters are dynamic in nature. You're trying to add or subtract different functionalities day in and day out. So Kordent acts as that source or that truth that helps you manage your clusters in a dynamic on demand way. And of course, security and compliance very important in today's world. There are multiple audits happening. We are moving towards certain compliances, matrices. Even in Europe, we see how the DORA compliance has come into place. So Kordent is trying to address all of this as an open source tooling. The key design, of course, is the templated approach that we follow, which is nothing but in form of YAML, where you are able to fine tune templates according to your own needs, the cluster spec, uh, the node spec, or how you are wanting to tune it according to your containers. So the templated approach and the unified management makes things simpler for Kordent or as a tool to be utilized. So this is the architectural view. I think we have spoken a lot about it, so I won't go through it. I have three components: the KCM, which is helping you manage the life cycle of your clusters; the KSM, which is helping you manage the life cycle of your services, the add-on services or the runtime state; and then the KOF, which aggregates matrices, logs, traces, and also helps you with the FinOps side of things. So let's just talk about a few open source components that are used under the hood for the cluster manager side of things. Of course, we are using Cluster API, and there's K0s and Cosmotron, which helps with the hosted control plane side of things. From the state management side, we are using Flux, SvelteOS, which is a very popular tool from an add-on controller aspect, helps you manage your add-on controllers. And then the observability and FinOps, you use OpenCost, Prometheus, Grafana OpenTelemetry, and some of these tooling which Dennis will cover. So this is how Kordent has been built, and this is, as you can see, somehow how we are trying to fit in Kordent in your IDP, or how different components of Kordent fit in from the basic layer, which is the infrastructure, the platform layer, till the observability aspect, how you are able to manage your clusters. Kordent comes into play, or you can utilize Kordent, building a complete cloud service platform, or as I said, platform aggregator. And you can find Kordent on GitHub, of course. This is a QR which helps you reach the main repo, which is basically just giving you information on what Kordent is, as I spoke about, and then redirects you to the other components, the KCM and the KOF repos as well. So quickly, we'll talk about the community. We have our community calls on the fourth Thursdays of the month at 9 a.m. Pacific during summers, and I think 8 a.m. Pacific during the winter season. The community meetings involve discussions around the updates, of course, to KCM, KSM, and KOF, and then we also discuss user stories or any other updates on the roadmap side of things, or how Kordent is being built. So make sure you're joining the community calls as well. So with this, I'll let Ekaterina take over, share updates on KCM with us, and then we'll have Dennis and Alexei talk about KOF, and Wahab about the state management side of things. All right, Ekaterina, you can take it forward from here.
Thank you so much. Let me share my screen because I have some slides to show you. Okay, so I'd like to walk you through where we started as the Kordent cluster management team, what we've built together and over the past year, and how Kordent transformed from initial idea to something that really can be used in production. Because this is basically a story about turning an early prototype into a real production-ready platform. So from day one, our goal was ambitious but clear. We wanted to make Kubernetes cluster management consistent, simple, support multiple infrastructure providers, and fully leverage the open source ecosystem. And of course, deliver an extensible cluster management foundation that other teams could build on. Cluster management sits at the very heart of Kordent. Everything else in the platform is layered on top of it. That core is powered by Cluster API, as we previously said. That gives us a standardized and declarative way to create, upgrade, and operate clusters across multiple environments. Over the past year, we've been transforming this concept into something robust, flexible, and ready for real-world use. But where we started? A year ago, Kordent existed as a very simple cluster management platform. At the point, we could deploy clusters on a limited set of providers. We had AWS and Cosmotron only. We could provide basic credentials and access management system, and supported AMD 64 only, collected almost no telemetry, etc. Also, and importantly, we didn't have any real backup solution, any identity and authorization management, any provider diversity. But I wanted to mention that even then, Kordent was designed with flexibility in mind. And from the very beginning, the platform supported customization through custom cluster and provider templates. That meant users could adapt it to their own needs by building custom templates. Kordent supported it from the very beginning. So despite the limited out-of-the-box providers, the system was already extensible and flexible. But again, apart from that, upgrades were scary, and failures were risky, and recovery often meant manual work. And over the last year, this is what we focused to work on to change. Let's now walk through the most important improvements we've made as the cluster management team. Credentials and cluster identity distribution. Different providers in Kordent have different cluster identity resources API. I mean, the objects where the cloud credentials actually stored. And since Kordent supports multiple providers, it's important to manage multiple credentials and identities in a simple and reliable way. And what we did to achieve it? We improved our cluster management, our cluster identity distribution and access management system a little bit. Now it allows to automatically distribute the provider's cluster identity resources across different namespaces. The user now can define credential and cluster identity resource once in a system namespace, and all the rest is done automatically by the KCM controller, and user can use this credential in another namespace. As I previously said, early Kordent didn't have any real great backup solution. So if your management cluster went down, then recovery was mostly manual. If a user made a configuration mistakes or an upgrade accidentally failed, rollback was really complicated. But for a cluster management system, this is very important, and we focused on changing it. To address it, we integrated Velero as our backup provider and built a full management backup workflow on top of it. And this gave us a support to backup all Kordent managed configurations, recreate management state from a specific backup without reprovisioning cloud resources, restore Kordent on a different management cluster if something went wrong with the previous, and manually restore to a known good state after operational mistakes. And I think this fundamentally changed how safe Kordent feels to operate, because backups turned Kordent from fragile solution into something that is recoverable. Next thing is telemetry. As the community grew, we lacked visibility into how Kordent was actually being used. We didn't know typical cluster sizes, Kubernetes versions, GPU usage, and some common deployment patterns. Without that roadmap, decisions were guesswork. And to achieve it, we introduced anonymized telemetry collection and sent aggregated metrics to segment. Telemetry now captures cluster sizes, versions, GPU, deployment characteristics, and this really helps us understand real-world usage and prioritize reliability improvements. Also, an important note is that no personal data is collected. Everything is anonymized because user privacy is fully preserved. Identity and authorization management. Early Kordent was functional, but we needed proper authorization primitives and a consistent way to provide authentication across all managed clusters. First, we integrated RBAC Manager from Fairwinds that lets users declare desired authorization state via custom resources, instead of manually configuring roles, role bindings, or service accounts. Second, we introduced a new custom resource, cluster authentication. This custom resource defines how the Kubernetes API server on the managed cluster authenticates requests. It can contain any external identity provider definition, multiple JWT authenticators, even custom certificate authority, and other authentication configuration options. Internally, Kordent KCN controller transforms this object into a standard Kubernetes authentication configuration. Kordent controller puts this file with this configuration on Kubernetes cluster nodes and launches an API server with the authentication configuration flag. As a result, we have a unified, declarative, reusable way to configure authentication across all managed clusters. Another thing I wanted to talk today is regional cluster, because this was one of the most impactful architectural changes. Originally, we had everything lived in one place. We had only management cluster. That made isolation difficult because the management cluster stored everything, Kordent API, hosted control plane components. And we needed better separation of concerns, and we needed a way to host control plane pods in case of hosted control plane clusters in a separate cluster. So to achieve it, we introduced regional clusters. And now users can register additional cluster as a regional cluster. That gave us a slightly different model. The model became the following. Now we have a management cluster which acts as a control plane, a single control plane, like a single pane of glass, where your cluster deployments, templates, backups, and other Kordent API objects are stored. It contains KCN controllers and Flux controllers, while regional cluster is a separate cluster where the actual infrastructure and hosted control plane pods live. And this creates a clean split. So in regional cluster, we have the following list of components, while the management cluster is separated with only Kordent API. And additionally, if desired, the management cluster can be used as previously with all regional components installed. Anyway, it unlocked a new deployment patterns and gave our users much better isolation. Let me also quickly highlight a few broader wins from the past year. As I previously said, we started with AWS and Cosmotron providers, while now Kordent supports around 10 providers, including GCP, OpenStack, and VMware. Of course, Kordent always supported custom provider templates. This is just the list of supported providers in place. Over the last year, we shipped more than 13 releases. And now we operate on a monthly basis, monthly release schedule. We even think to make releases more frequent, to have 2 weeks release schedule, to make our users confident. And of course, a huge part of the last year was focused on reliability, fixing bugs, tightening reconciliation loops, strengthening core cluster management behavior. And this work is not the most visible work, but it's what transforms a prototype into something that people can really trust. And finally, documentation. The last year, docs coverage improved dramatically. We now have step-by-step guides, examples, some real-world use cases. That's very important because good docs turn features into usable features and make our project really better. So where does that leave us? Kordent 1 year ago was early stage cluster management. And today it is a platform with multi-provider support, real backup and disaster recovery, unified identity and authentication, regional architecture, telemetry-driven development, and regular releases. And it's just the beginning. So looking ahead, we focused on greater stability and reliability, including hardening core workflows, broader integrations across cloud providers, infrastructure tools, and the Kubernetes ecosystem. A better user experience with simpler onboarding, clearer workflows, deeper automation from day 0 cluster creation to day 2 operations like scaling, patching, and lifecycle management. And of course, more extensibility, so teams can customize Kordent to fit their own platforms and processes. Actually, our goal keeps the same, to make cluster management simpler, more predictable, and more accessible, while continuing to grow and shape the platform together with the community. I think that's all from the cluster management side, and let me stop sharing my screen. I'm going to pass the floor to Wahab.
Thank you, Katarina. So let me share my screen. So I'll be talking about the state management part of Kordent. State management is the part of Kordent that we use to manage applications or services, or as we call them, beachhead services, on the clusters that we create with the KCM controller. So just continuous lifecycle management of these of services on these clusters. And just as we have cluster templates, we have service templates for Kordent state management. So it's also template driven, and these templates live as service template custom resources. With the Kordent state management, we also provide an interface that can be used to support any third-party provider for state management. So if there's a state management that doesn't come packaged with Kordent, but somebody wants to use it, they can integrate that with Kordent state management. Currently, the KCM and KSM are packaged as a single binary. So when you install Kordent, the KCM controller contains both the state management and the cluster management part. So moving on to some, let me just, So moving on to the KSM architecture. So this is an architecture diagram that's from the user perspective. So when we have a service template which defines a service that should be deployed on any clusters, we look at an example of service template later on. So when a service template is used with either a cluster deployment or a multi-cluster service, both of these are Kordent specific objects. The cluster deployment is used to manage a single cluster. The multi-cluster service, as the name suggests, is used to manage services on multiple clusters. So we can use the service template on either of these objects, and the controller, which is the KCM or the KSM controller in this case, it reads that spec and it creates a intermediate state management object that we call a service set currently. It works, it's analogous to how a replica set is created for a deployment type in Kubernetes. And with the use of this intermediate object type, we can then have any number of state management providers, and then they, with their specific adapters, they can then manage that state intermediate object called a service set and create a platform specific object that they can then deploy the services with. So currently, so if there's if somebody wants to deploy and integrate a third-party state management solution, so they'll have to implement a KSM adapter for it, and then that can be and install the KSM adapter, configure Kordent to use it, and then we can use that. Currently, by default, Sveltos is used as a state management provider, with Sveltos KSM adapter deployed by default and implemented by the developers at Kordent. So let me just show you an example of what that looks like. So I have Kordent installed on this machine. So if I look at state management providers, we can see we have Sveltos state management provider currently installed. So if you look at the definition of this object, so we have an adapter and a provisioner that provisions the actual services, and then the CRDs that are specific to that provisioner. So with this object, we can then we can plug in the state management provider with Kordent. So by default, we have Sveltos in it. So if I move on to the next slide, so this is an example of the service template. So these templates are namespace scope, and they can use either Helm or customize sources, as you can see in this example, and they can have multiple backends as well. So we're using Flux to provide the backends for these templates. So we can have the Helm chart or the customized object can be stored in a Helm repository or a remote source if you're using customize. And these are some examples of the service templates that we can have. And of course, these service templates are fully customizable, so anybody can create their own custom service template by following the CRD example. And so when using these service templates with a cluster deployment or a multi-cluster service, this part of the YAML is relevant, the service spec. So with the service spec, we have the provider specific configuration and the services that we want to install. So to give a better example, let's look at some examples for cluster deployment. So we have this cluster deployment YAML. So this deploys the cluster itself on AWS in this case. And then with the service spec, we specify that we want to use the Sveltos provider, and the Sveltos specific configuration lives over here. And then we can define any number of services that we want. And these are the service templates themselves, the cert manager in this case. And we can also provide Helm values right over here. So an example for multi-cluster service is exactly the same, with the difference that we now use a cluster selector for a multi-cluster service to match the labels on these, to match clusters with these labels. And this spec is the same as the cluster deployment, but we're just using multi-cluster services. And then we have features like dependencies between multi-cluster services. So you can, ask the multi-cluster service 2 to depend on multi-cluster service 1. So this object, multi-cluster service 2, will not deploy its services until the multi-cluster service 1 has deployed its services on each cluster that it matches. So these are some of the examples that how service templates are used with multi-cluster services and cluster deployments. So let's move ahead. And then, we have a website called Kordent Catalog, which has a curated list of some of these service templates, as well as some provider templates. So if you look at the catalog website over here, if you want to install Cert Manager, you can search for Cert Manager, and it will provide you with instructions on how to install the specific service template called for Cert Manager, and how to verify that it's installed. So it's a convenient place to install some of the more popular applications from. So this is a slide which summarizes some of the projects that we were considering for state management to be used as default in Kordent, and some of the things that we were considering. Is not an exhaustive list, but some of the more notable things that were being considered. So as you can see with Sveltos, it matched all of most of the things that we wanted. So like it could auto discover CAPI clusters, it had centralized definitions, it was multi-tenancy capable, and very importantly, it didn't require any GitOps specific knowledge for users to use. So that led us to the decision to implement Sveltos. But now, as we discussed, we have a state management provider type in Kordent, so we can now we're not just bound to Sveltos. We can use any other provider with a specific adapter for state management. So these are some of the features that I wanted to mention that Kordent state management provides on top of whatever provider that is being used, for Sveltos in our case. So we have something called service template chains. So with these, when you define these chains and you use these chains with a cluster deployment or a multi-cluster service, so it has an upgrade path, and that enforces, and KSM makes sure that you cannot upgrade to a version that's not mentioned in that chain. And as a consequence of these chains, we can also do automated sequential upgrades. So for example, if you have a version 1 installed of version 1 of a service installed, and you have a chain that goes from version 1, version 2, version 3, and up to version 4, and let's say you want to upgrade it to version 4, but you don't want to do it manually, so you just specify the target as version 4, and Kordent state management will walk through all of the upgrades from version 1, 2, 3 up to 4 automatically. So it creates a more convenient management for if you have multiple clusters and a lot of services to manage and upgrade. Then we have access control and distribution for these service templates as well across namespaces with our access management CRD. So you can use that this mechanism to provision service templates to some specific namespaces, just for more control and greater separation. And then, of course, and then we have inter-service dependencies. So you can ask KSM to not deploy a service until some other services have already been deployed. So we can define service dependencies with between services in a cluster deployment or a multi-cluster service spec. And then we can similarly we can define these dependencies between multi-cluster services themselves. So we can define that within a multi-cluster service that for every cluster that it matches, do not install any other service until you have installed a cert manager, for example. So these are some of the features that KSM provides on top of some state management that's actually doing the provisioning. And we have some other features as well that are in very early stages of discussion. So as an example, we have a multi-cluster. The multi-cluster service that we have is cluster scoped, but we're thinking about some use cases that would be needed where we want to have a similar object to multi-cluster service, but it's namespace scoped. So things like that that are still in early stages, and definitely we'll have other features as well. And these past few releases have been focused on stability and bug fixes for the most part, which is important for us to make state management and Kordent experience as a whole more stable. So that's what I have for state management. And I guess I'll pass on to Dennis.
Thank you, Wahab. So let me share my screen and show the slides. 1 year of KOF, which is Kordent Observability and FinOps. So we had about 14 releases starting from February of 2025, where it was really beta version. Then the first like version 1 in the May, and now we have version 1.7 released in February 26. So it's really 1 year. You can get full information on the GitHub releases page of Kordent. But in this time, we made like 500,000 of commits with a lot of new features, fixes, actually a lot of improvements, which were not even tagged with all these tags and commit messages earlier. Now there. So what is KOF? It is full stack observability. It has these main components, features, and they are implemented in this specific way. Let me walk through this because this is the most important like high-level picture of what KOF actually provides. So first of all, it provides collectors. These collectors are backed up by OpenTelemetry, OpenCost. They look into what happens in your clusters and collect this data and export it to storage. The storage is provided by Victoria Metrics, Victoria Logs, Victoria Traces, and also we can store, for example, logs in third-party storages like AWS CloudWatch or whatever you can imagine. Then there is aggregation layer. For metrics, we use Proxy, which is Prometheus proxy. And coming soon, there is our own Kordent Vlogsy, which is kind of proxy, but for logs. And this aggregation layer, it allows to collect all this data to a single pane of glass, to visualization layer, which initially was Grafana dashboards. Now it is optional. You can use it completely without Grafana. We also have our own KOF user interface, which is very helpful for debugging all these interconnections between all these components. Support for alerting with alert rules and roles through the alert manager, and also the events, which is also can be visualized in dashboards, for example, or elsewhere. The security layer includes single sign-ons using DEX, this new multi-tenancy feature that I will talk through soon, and this recent addition, which is not released yet, but will be released soon, about access control for even stricter security here. So, by the way, as a side note, Ekaterina mentioned that in the core of KCM, there is a telemetry component, and that telemetry is anonymous and used for like understanding of what loads we need to process. This telemetry is different. It is never sent to Kordent. It is just for you, or just for the customer, so that you can look into your clusters and see what's happening there. We support different clouds like AWS, Azure, OpenStack, and others. Actually, whatever Kordent itself supports. We tested with few of these clouds. And the last but not the least is auto configuration feature of KOF. We use these multi-cluster services that Wahab was talking recently about, and our own KOF operator to augment this functionality. And we have a kind of sister repo called Kordent Istio, which allows this automatic networking between clusters without any needing external DNS, etc. So this auto-config is actually probably the most important feature of KOF, because it allows to apply all this full stack to child clusters and regional clusters kind of magically, automatically. So, for example, this is a cluster deployment Wahab also mentioned. And you say that I want to deploy this cluster with this name. And then the only thing you need to do is just to attach a label called KOF cluster role. It can be child or can be regional. And with this one line, you actually activate a lot of automation, which installs all these specific components to selected clusters and connects everything. So, for example, if you have child clusters in some region, for example, East 1, and these child clusters will automatically detect the regional cluster in the same region. You can definitely customize it if you want, but by default, they find their regional cluster automatically. And the child cluster in another region, it finds its own regional cluster. And so they send all their metrics and traces and logs to these regional clusters. And then the regional clusters aggregated further to the management cluster. Actually, it is management cluster which queries the regional clusters, because the storage is actually happening on the regional clusters to make it scalable. The recent addition is multi-tenancy. So this is very new and very important label called KOF Tenant ID. It allows us to kind of create organizations, tenants. And for example, in this example, we have 3 child clusters, and they're in different regions, but they're all are in the same tenant. And we have different tenants there somewhere. And the interesting part about tenants is that now there are no shared credentials that were used in the earlier versions of KOF like a year ago. Now it is really secure, and each tenant uses its own specific credentials. Actually, even each cluster uses its own specific credentials to send the data to the storage and to connect everything. So the security is enforced now very tightly here. So speaking about docs, we have this big section in Kordent docs in this admin/KOF prefix. And let me really quickly make a really high-level tour to show what's happening there, mostly about diagrams and where to find what, because it's really important when you start using KOF. You kind of face that there are a lot of things that can happen, and you can connect it and use it in multiple ways. So it's really important to understand where everything is located in quite extensive documentation. So the main page about KOF, it contains general information about use cases, like when and how do you want to use it. And then there are sub-guides. This architecture shows really high-level stuff that I already showed, that there is a management layer with proxy and so on, loxy, which is aggregating stuff from storage regions that collect metrics and logs and traces from child clusters. There is also, not diving into details, but if you want to look into what's actually happening inside of management cluster, inside of regional cluster, inside of child cluster, you can see all these charts and everything that Helm charts and everything that is installed automatically there to make the data from observed objects flow from child to regional and to management. So the most important page is actually installing KOF, because it is also applied when you upgrade KOF or when some new features arrive. We definitely have a separate upgrading KOF page, but this installing is the most important one. So there is a diagram with multiple options like clouds or air gapping or networking or DNS options, where the regional is stored, where do you want to store management data, etc. So as you see, the options are quite big, and all this configuration is kind of complicated, and we are working on this. For example, in the next release, we will introduce one single KOF chart, which will install all the others, like one ring to rule them all. So, but for now, yeah, it is quite documentation based to install and to configure everything. It can be used together with Istio. We have this special Kordent Istio chart. And it goes through the management cluster, how to configure it, the regional cluster, how to make this regional cluster deployments, child cluster with child cluster deployments and this cluster role that I showed, and so on. There are some sub-guides about, for example, how to use this new KCM region concept that was introduced recently, this kind region, and how it can be used with KOF correctly, how to connect and attach everything. There is a guide about how to upgrade from one version to another. So there are sometimes specific things to apply, and definitely instructions to backup your data to keep everything safe. This verification page shows how to verify that everything is correctly connected, because this is quite a complex setup. And so to be sure that everything works, we have this verification options, including our own KOF UI, which I mentioned. This storing page is kind of a hidden gem, because recently one user asked how can we store data not inside of the Kubernetes clusters, but somewhere outside in third-party storage. So I just sent a link to this page, and the question was answered, because we have really a lot of options about where and how to store data. So all these cases are covered here, how to configure them. Using KOF is the page about how to use the KOF now that Grafana is optional. So how you can access metrics and others using different UIs or APIs, logs, traces, etc. Cost management backed up with OpenCost. This page is about Grafana, which is now optional. And so if you want, you can install and enable it yourself, and you will get a collection of Grafana dashboards and all this connectivity out of the box. KOF Others is quite an extensive guide with a lot of information and diagrams and knowledge about how to set up all the alerting stuff. We also have scaling guidelines, how to maintain KOF, this notes about tracing, this really new feature about KOF multi-tenancy with this KOF tenant ID, which I mentioned, and with details about how all of this works. Really important for production use cases is retention and replication. So here you can find some recommendations about this, resource requirements, and so on. So going back to the slideshow, actually that's it. Thanks everybody for contributions, for using KOF and for considering to use it. I guess that's it for me.
Thank you so much, Ekaterina, Wahab, Dennis. That was a lot of things, a lot of updates, a lot of insight on how things are looking for KCM, KSM, and KOF. Before I move on to our concluding slide, are there any final comments? Is there anything else that you would like to add, or we can conclude our webinar for today? I know we have gone on for almost an hour, so that's a lot of info for folks to get in, absorb. Any final comments from you folks?
I have a couple of words. Well, for me personally, it's been very exciting to be a part of Kordent. And during the last year, Kordent has transformed from an early cluster management into some robust technology with service management, with observability, and that was really great. And I want to say thank you to all of our contributors and to our community. Thanks.
Absolutely. Thank you so much to the community. I remember, just adding to what Ekaterina said and agreeing to her, I remember one of these community members from Capgemini stating that he wanted to take a look at Cluster API and Svelte OS and OpenTelemetry, but then he was able to find one tool that's Kordent and everything in the same, and that's been such a savior for him. So I echo his words and Ekaterina's words on how Kordent has grown over the year. Right, any other last words from anybody else? All right, I guess none. So we will quickly jump on to a couple of slides before we conclude. One of them is contributing to Kordent. So, of course, you can check out the contributing guide on the main Kordent repo, where we have put in all the information on how you can get started. There are a few good first issues if you want the maintainers to help you with a few good first issues. Make sure you are taking a look at them. Make sure you're able to find out some issues that are already listed on the KCM or the KOF repos and the other repos as well. You can contribute something to the service catalog as well if you feel like any other tooling that's required as a template. Roadmap discussions can be part of the GitHub discussions, so you can start a conversation or you can add something as an issue or a roadmap item, and hopefully we'll see the maintainers and reviewers who we are trying to nominate in our future calls to help with the same. Last up, join the Kordent community. We are on the CNCF Slack, so you can scan the QR to join the CNCF Slack, or it's slack.cncf.io. Or if you are already on the Slack, make sure you're able to join in. With this, we wrap up today's webinar. It's been a good time recording this and having everyone from the Kordent team here. Thank you so much, everyone, for joining in, and we'll see you soon with another Kordent CNCF webinar. Thanks, everyone. Bye-bye.
Bye.
Thanks. Bye-bye.
Bye.